Hello, everyone. Welcome to this webinar, Making Serverless a Game Changer for You, at exact 11 a.m. on the 22nd of the 11th month in 2022. What a special date. So in this webinar, we talk a bit about the what, why, and how serverless can be a game changer for you. And just as a disclaimer, this is a rather technical webinar. So I assume you are familiar with the terms API, virtual machines, and container. So some technical terms you should be already familiar with. So let's get started. My name is John. I'm the host for today. I'm a cloud engineer at Kreuzwerker, and I've been working with serverless already for almost 4 years. Started as a full stack, as a web developer in PHP, then transitioned to DevOps, and now I consider myself more as a full stack developer, but officially I'm a cloud engineer here at Kreuzwerker. So the agenda for today is we talk about the what is serverless. So we will list the benefits of using serverless, but also the things you need to consider. Then we particularly talking about serverless on AWS, because AWS invests a lot in serverless technologies and offers a lot of serverless services. Then, like I said, it's a rather more technical webinar. We will talk about a serverless architecture pattern using functions as a service, especially how to use Lambda, or focusing more on Lambda. Then we see examples, and then a quick demo. And by the end, we have time for Q&A. By the way, you should see in your Zoom the Q&A button where you can type any questions, and hopefully then we can, then my co-host Ali-Chan will support me and ask me the questions, and hopefully we can answer all of them. Before jumping into the talk, since we work for Kreuzwerker, let's give a brief history about what is Kreuzwerker doing. Kreuzwerker is Berlin-based, or now we have 5 locations. It's a consultancy company with focusing on cloud development, but not only cloud development, but we also have we are also Atlassian Premium partner. So whenever you want to set up Atlassian products like Jira or Confluence, we are there to help. But yeah, this talk is rather, this is more about talking about AWS and using serverless with AWS. So we have 140 employees, and yeah, we are AWS partner. These are the deliveries or the competencies we currently have in our portfolio. So there's also Lambda delivery, which is a serverless service, DynamoDB as well. But we also do like from cloud modernization and cloud migration. We also do cloud development, where serverless may fit quite well. So let's go to the topic, what is serverless? Let's imagine a world where you never have to worry about servers, where developer can ship code faster and get immediate feedback without having operations team involved. where your application scales automatically and is high available 24/7, and where you pay what you use. So I hope you get an idea what serverless is. So let's summarize it. So is for when using serverless, you have less time managing cloud infrastructure. That means you can deliver the value or your business or the application faster, get faster feedback. You have also less operational complexity, because there are no servers underlying which you need to manage or patch. And with that, also that means there are no costs for maintenance or patching them. And it scales with usage. That means it scales automatically. So you don't need to think about in advance, okay, I have an application and what happen if there's a huge usage of my application. Serverless scales automatically. And of course, it's also not scaled automatically up, but also scales automatically down, meaning you don't need to pay for idle capacity. And it is high available. That's what it's meant with 24/7. It's that's managed by the cloud provider. So you always can be sure that your service is always up and running. And you pay only what you use. Of course, there are things to consider. So testing and debugging become more challenging. So because serverless is more distributed, you have to think of how you want to debug your application. So where do you want to store the logs and how you can access these logs. And also testing becomes a little bit more challenging. Of course, you can try to test it locally, but it might be different than once it's deployed. Then you are also vendor locked in, meaning whenever a cloud provider is offering a serverless service, you have to follow the rules, so to say. You have to follow the guidelines the cloud provider is providing you in using this serverless service. So for example, there is a function as a service on AWS. This function as a service looks different than the functions as a service on Microsoft Azure or Google Cloud Provider. So this is meant with vendor locked in. So you have to use, when choosing the serverless service, you have to use only this from this vendor. It is a relatively new technology, which requires additional knowledge. So all the serverless technologies, like I said, you need to follow a rule, a guideline, and this is which requires additional knowledge and which you also get to familiar with. And it can get expensive. What I meant with that is there are hidden costs like other services. For example, if you use, I mentioned already the distributed fashion, which is a characteristic of serverless. So you always need other services, and these services may be hidden at the first place because you say, okay, I want to use the function as a service, but I also want to log my functions or the outcome, and therefore I need to use a different services. But it's also the same happen for server full application, because there you have to maintain operational cost or maintenance cost, or even people who are maintaining the server for you. Here you can see an example when using low compute versus high compute. So in this case, you see an example on the left side. You see the function as a service from AWS, Lambda, compared with their virtual machine service, EC2. And so what you see here, you have like an allocated memory of 512 megabyte, and you have a number of invocations 20,000 times per month, where the execution duration of one single invocation is take maximum 1 second. And this is the calculation of a Lambda. You can see in total for this month cost you 17 cents, whereas an EC2 instance, which is running 24 hours, 30 times, so 30 days, so 1 month, it costs you like $5.83. And this is already the tiniest, the smallest instance type. But yeah, you can save a lot of costs, as you can see here. Whereas on the other side, if you use high compute usage, so high compute use cases could be like processing images or processing videos. There you need to increase the allocated memories to more than 2 gigabyte of memory or where you at least need 2 gigabytes of memories. And this time we have a bit more traffic. Like let's say we have 30 million times or number of invocations per month, and the duration time would be 500 seconds, which is, I think, more than 6 minutes. And this, as you can see, can get quite expensive when using AWS Lambda compared to a bigger EC2 instance, which is also running 24 hours, 30 days. Yeah, you can see that Lambda would cost like 4 times more. But also here it is disclaimer, because these numbers of this is just a theoretical number, because you can also say that these 30 million number of invocations. So here we assume that the 30 million invocations are happening linear, but it could also happen that you have a specific time, like this Friday, for example, there's a Black Friday, and then you expect like high usage of invocations, or you expect high invocations of your application, and that would mean that your EC2 instance might not be able to handle these numbers of invocation within this one single day, and you might consider putting 2 EC2 instances, whereas Lambda, you can be sure it scales automatically. So yeah, this, but generally, if you know, if you already know when the invocations happens, and you can already predict or you can do sort of like a saving plan, then of course, in this case, Lambda would be much more expensive than running EC2 instance or virtual machines. So like I said, we are partners with AWS. So that's why we're focusing also on serverless technologies on AWS. And AWS has 3 different categories. One is the compute, which is basically running your code, so to say. So there's one, I already mentioned it, called AWS Lambda, which is the function as a service of AWS, where it's only required your code, and you don't need to provision any servers or cloud infrastructure, and this code just runs. And then we have Fargate, AWS Fargate, which is the container service of AWS. So let's say you have a Docker container or you have a Docker image and you want to host it on AWS, then you could use Fargate. I think the illustration shows it pretty well, where it says it managed the underlying EC2 instance for you, and you don't need to worry about the underlying server. So that's the container service of the serverless container service of AWS. And then we have another compute service. It's called AWS Glue, which is more like the data or the serverless data integration service of AWS, where you can mainly do ETL jobs. You can also say, yeah, Glue is maybe a stronger Lambda, because Glue is able to process big data. So Glue comes with Apache Spark, which is a big data technology or big data compute processing technologies for handling big data. Yeah, it comes with Spark out of the box, but it can also handle just Python. But yeah, you are a bit limited because you can only use Spark or Python, and with Lambda you are a little bit more flexible. Then there is another category, it's called application integration. So there's one service called SNS, which stands for Simple Notification Service, and there you can create a topic, or in short, it's a pub sub service of AWS. So you can create a topic where everybody can subscribe to, and whenever somebody is sending a message to this topic, then all subscriber gets notified. And one, I think, pretty common or pretty popular service is the API gateway of AWS. So like the name said, it's an API gateway where you can call this API gateway and then it routes via endpoints to the respective serverless service. Mostly it's connected with Lambda. So yeah, API gateway is the service you call first, and then according to the endpoint you are calling, it then routes to the respective service. Then AWS also has a queue service called Amazon SQS. So that's where you can send messages to a queue, which then can be processed by a target, or the client can pull this information from the queue. And then we have AWS Step Functions, which is an orchestration workflow service of AWS, where you can create steps inside a workflow, or you can create workflows which consist of steps. So for example, you could do like ETL with step functions, saying, okay, one step could be like getting data from the database. Then it's called a Lambda for transformation, for example, casting strings which supposed to be integers to integers, and then load them into a database. So this could be easily orchestrated with step functions. Then we have also serverless data storage services. One, I think the most popular one is Amazon S3, which is an object storage service of AWS, where you can store any kind of data in there. And then we have one serverless database called Amazon DynamoDB, which is a NoSQL database. NoSQL means you can store your data in unstructured format. So in comparison with the Postgres database, where the data is structured, this is rather unstructured. So you don't have like a predefined table, so to say. So you can really store the data unstructured, in an unstructured fashion. Okay, these are the services of AWS. And now we will focus a little bit more on function as a service using AWS Lambda. But again, as a disclaimer, serverless is more than just fast. So we have seen the container as a service Fargate. We have seen serverless storage option. So serverless is more than just Lambda or function as a service. So what is AWS Lambda? So AWS Lambda is an event-driven serverless computing service of AWS. It is ephemeral, so meaning it's stateless. So whenever it gets triggered, it fires and forgets basically. So you shouldn't save anything with using Lambda, or you shouldn't save anything on the Lambda, but you can use Lambda to save something for you. And Lambda, you can use, or you can program Lambda with different runtimes using Node.js, Python, Java, Go, C#. Or if you are more a PHP developer or Rust developer, you can also create custom runtimes, or even use a Docker image to invoke your Lambda. So what is an event? An event could be from an API gateway. Let's say you as a client, you are calling a browser, or you're calling an endpoint, and the API gateway takes this endpoint and then knows where to route to, and then triggers a Lambda. And the Lambda gets triggered by receiving this event. Okay, somebody just did a post HTTP request by want to add a new node, or add a new item into your cart, for example. Another thing, so this is quite popular, and we will also see an example, but Lambdas can also be triggered by, for example, S3 trigger, meaning whenever somebody is putting something into an S3 bucket, then it can trigger a Lambda. And yeah, I think this could be useful if somebody uploads a file, an image on S3, then it triggers a Lambda to maybe process the image, maybe make it smaller, or maybe blur out faces and so on. And yeah, so there are also more events like the DynamoDB streams. So whenever the DynamoDB table gets updated, then DynamoDB sends out a stream, meaning sends out an event to trigger a Lambda. So there are also ways to do customize events, but I think these are the most popular or most popular events when triggering a Lambda. So, and examples. So one example is the microservice pattern. So the client here calls a REST or an HTTP endpoint. And this, let's say he or she is using, wants to read from the database. So he or she is calling a GET request. So triggering a read lambda, which is interacting with the database. In this case, it's a RDS database. So it could be Postgres, could be MySQL. And so the client is asking, get me all the products from this web shop. And then the read lambda gets triggered, getting the information from the RDS database, and then returns it back to the client, which is usually an application, so a front-end application which consumes this data, the returned data. So same for create. So this talks to the RDS database. I call it microservice pattern because microservice means you can see each lambda as an individual service, which talks separately to its own database. So it could be dynamic. It could also be connected to, in this case, DynamoDB. For this application, it does not make sense, but I wanted to show you that what microservices are. So Lambda can be seen as its own service, which could talk to its own database. So they are all decoupled from each other, and the API gateway knows where to route to trigger these to trigger the Lambda, sorry. And yeah, this is by far the most popular pattern when using function as a service. So always connecting lambdas with an API gateway, and then the client could be like your front-end application, do an HTTP request, and then the lambda is interacting with the database. With the rise of event-driven design, AWS is having this Amazon Event Bridge, which means your application can emit events, and this can be then consumed by Event Bridge on AWS. And according to some events, you can then trigger step functions where you can, I don't know, like start a workflow processing, for example, images also, just as an example. And whenever there's a failure because the image, for example, is too big or not in the right format, then the step function could send a message to the queue, and which then can be processed by a Lambda, for example, to do a retry mechanism, or maybe to send, or it can send an SNS topic to notify the user, hey, something happened, or hey, you used the wrong format, or the image was too big. Another example would be ELT. So in this example, you see we use DynamoDB table, and whenever something happening on the database, let's say there's a new entry happening, then streams get triggered and send out an event to a Lambda, and the Lambda, okay, got this event and save it to a data warehouse. And in this case, it's a Redshift, or could be any kind of data warehouses. And then you can use a third-party tool like dbt for using transformation. So when creating serverless applications, it could be could be kind of hard. So that's why there are a lot of tools out there which already have the name, have serverless in their name. So, for example, serverless framework, which is I think the first framework which created serverless application. And we also have from AWS SAM, the serverless application model. They both use YAML, and they all here, you can see they use CloudFormation under the hood. CloudFormation is an infrastructure as code tool of AWS. And the key difference is AWS SAM is created by AWS and works only for AWS services, whereas Serverless Framework is a community tool, an open source tool, which also can do Microsoft Azure or Google Cloud. They both use YAML, but I would say AWS SAM is able to do Node.js lambdas and Python lambdas, whereas with Serverless Framework, maybe it got a bit better. I haven't used it for a while, to be honest. But back then it was mainly optimized for Node applications, whereas SAM can do Python. So it can do the dependencies with Python a little bit better than Serverless Framework. Then we have this AWS CDK, which is a new way to use define your infrastructure to code by using a abstractive programming language like JavaScript or TypeScript, Python, Go, C# or Java. And yeah, because creating or writing CloudFormation scripts can be sometimes a pain. And then we have, here's one framework called Serverless Stack, which sits on top of CDK. And the key difference between Serverless Stack and CDK itself, with Serverless Stacks, you have constructs which create serverless applications out of the box for you. So there's a construct for creating API gateway and lambdas behind the scenes. So you have less code to write and therefore also less code to manage. I wanted to show you a demo, but I have currently a little bit trouble to set it up for you. But here you can see, so what you can see in the AWS console, you have the Lambda. So I wanted to show you a simple CRUD microservice pattern by using API gateway and Lambda, and that would store it into a DynamoDB table. So in the console, you see you have the Lambda here. You see also, so usually, so you see like where the trigger is coming from. In this case, it's coming from an API gateway. And as you can see, when seeing the Lambda, you can see the code lives here. That's the meaning of function as a service or the compute services, because you need to put the code somewhere. And here's one huge index JSON, which is written in Node. And yeah, you can see the code itself, but you don't. So you also have monitoring in place. You can configure them, but you don't need to SSH into to see the code, or you don't need to spin up a virtual machine to run this code. This is all done by AWS. And usually you have also the possibility to send an event in here. So there are already some templates for you. So most of the time in this case, it would be like an API gateway event. So this is how API gateway is triggering your Lambda. So with all this metadata, and if it would be a post request, then you also would see a body in here. Oh, you have like a query string parameters for having something like a question mark, and then everything which comes after question mark is like your query parameter string. And with that, you can test your Lambda and trigger your Lambda. So this is then connected to, in this case, a DynamoDB table. So maybe we can try to test it, but yeah. Unfortunately, yeah. Sorry for the the issue with live demos. I have used a serverless stack, because serverless stack also gives you a nice overview of all the functions you currently have. So serverless stack was this tool, which gives you a nice overview of all the APIs, all the functions, the DynamoDB table, and it's a pretty cool tool, I would say. But definitely all the other tools are also very, very good. And yeah, that's about the demo. And let me turn on the slide share. We also have a serverless readiness assessment for you. So if you now saw the cost, for example, we are there for you to maybe think, okay, you probably need high compute usage or not. So we are there to help you with getting into serverless, or to identify if you are serverless ready or not. And we offer you 1 3-hour basic assessment. For that, you can contact AWS at kreuzwerker.de. But also for other topics, definitely. You can find more about the serverless readiness assessment under aws.kreuzwerker.de/serverless. And you can also get a call with our CTO, Tine, to gain more serverless clarity in just 30 minutes. We will share these slides with you, and you can, schedule a call with her, but not just regarding serverless, any kind of cloud development questions. We are there for you. I also will put the references in here, so you can read on serverless in general. So this is a really nice website, serverlessops.io or serverless land. It's really recommendable to see different patterns using serverless technologies on AWS. But of course, also the AWS. I also took a lot from the AWS.amazon.com serverless page. And yeah, now I'm open for questions, or I'm happy to answer questions.
We have a couple of questions in the Q&A. Aber said, hi, everyone. Hi, Aber. First of all. And so Sharib has a question. In the microservice pattern example, what's the significance of using a separate Lambda for each CRUD operation? Or was the Lambda the same, one for all operations, but it was the trigger that we were showing in the diagram?
So going back to this example, to the microservice pattern. So what's the significance of using separate Lambda? Yeah, so it's always good to have like sort of like code splitting. That's, I think, also a good software development pattern, when you can say, okay, I have one Lambda for its purpose. So I have one Lambda which can do create, or I know there's a Lambda which is doing the read. So it's a matter of how you want to split your code. Of course, you could put them all into one Lambda and then, I don't know, define it via annotations, what this Lambda, or when this Lambda or this function get triggered. But I found out that if you split the code, then you can easily reuse them somewhere else. And yeah, if you have one Lambda for its purpose, you can also like create, for each Lambda, you could also create each a single database, or you could connect it with its own database without interfering with other Lambdas. So it's a matter of how you design your application and how you agree with the team on designing your application. I found it better if you keep the Lambda tiny, because also in terms of execution time, because under the hood, AWS is downloading this Lambda, and if the Lambda is big, then it needs more time to download the Lambda, which means it needs more time to execute. So try to keep the Lambda small and simple, and split the Lambda.
Yeah, I guess it's also nice to decouple, so that if, for example, the create component fails, then you know which component already failed. So it's better for fault tolerance. It's easy to identify what's not working, and it doesn't affect the other operations.
Exactly.
Okay, next question is from Bypath. I hope I'm saying that correctly. What practices do you follow to get rid of cold start of a Lambda function?
Yeah, so it's really hard to optimize Lambdas, I have to admit. So I always would say like code splitting is one. So like separating each purpose or each function into one single Lambda. So instead of putting these all functions into one fat Lambda, really split those. And then there's something which is why I like Node. So in Node, if you use the runtime Node.js, then you have the possibility to bundle your code. Bundling your code means it would put all the code inside just one single Lambda. So usually when you develop a Lambda, you should also do like code splitting. Maybe you use TypeScript, and then you split the code into modules. And with bundling the code, you would put them into one single Lambda, and you would, most of the bundlers also have like tree shaking mechanism, meaning you only use the functions what you use inside your Lambda. So let's say you have also a third-party library, but you just use one function from that third-party library. Then the bundler usually is intelligent enough to take only this function from this library without putting all the whole library inside this Lambda. So try to keep the Lambda small. So try to bundle. Try to remove dependencies. So let's say if you don't like Node.js and you don't like to bundle the code, you want to use it Python, then try to or just the necessary dependencies. And there are also like layers, Lambda layers, which you can use to keep your Lambda small and tiny. So I know this is a bit, that's why I said things to consider. It's a new way of developing your application, or new ways of developing serverless. But to keep the code start small, you have to keep the Lambda small. And there are some tricks how to keep it small by bundling the code or by using layer for your dependencies. I hope that answers your question.
Yeah, those are all the questions on our Q&A. I have a question on my own.
Sure.
So there's a custom, so you can basically use a Docker image and use any runtime you want to?
Yes. So Lambda now has the possibility to use custom runtimes. So you can use PHP, Rust, or I don't know, Haskell, if you're into these languages. Those are mainly Docker, so you can also try to develop your Lambda inside a Docker container, and then spin this Lambda together with the Docker container. Then you have your own runtime. So it's also happened that, for example, Python 10 is now out there, or Python 11, and AWS does not have supported yet, but you want to use Python 11, then the custom runtime would be the go-to.
Very nice. I guess that's all. Oh, there's another one. Would you prefer one language instead of the other to use with AWS Lambda? I guess it refers to, yeah, go ahead.
No, sorry. Would you prefer one language instead of other to use with AWS Lambda? So I would always recommend Node.js, because Node.js, you can really tiny your Lambda. You can really make it small, because most of the time, if you use Python with Lambda, you need dependencies, and these dependencies you also need to put inside the Lambda unless you use layers. But using layers is also kind of a maintenance overhead, in my opinion, because you need to maintain these layers. But in the end, you just want to deploy this Lambda. Whereas with Node, you can really bundle the code. It's also the same for Java. You can also, in the end, you can create a jar file, which is all bundled code. But I would say Node.js is my go-to, and this is also the first how AWS was inventing, or when they created Lambda, they also used Node.js for the first Lambdas. And I think now they also optimize, or Lambda is optimized when using Node.
Okay, and the next question is, what is your favorite serverless service in AWS and why?
Yeah, so definitely one of my favorite one is Lambda, because I was really annoyed by setting up servers. And with Lambda, you could just spin up this code, deploy the code, and it works for really. I had so many glue code back then, which for example, like just getting some information from the data, and for that back then I had to create a server and then read from the server, or log from this, or getting the logs from the server. And with Lambda, I easily could connect to a database. Another service which I'm also a fan of is step functions. The step functions, because usually I don't require just one single Lambda, but the step function I can have multiple, because most of the time I have a workflow, and with step function I can create a workflow without setting up a server or using Docker container or an application or whatever. I can use step functions because it's really easy to use, or I really like it to use, just to create a small workflow.
So in that's my question.
Yeah.
In step functions, is it possible to exchange data between lambdas, like using the output of the first lambda as an input?
Yes, you can do that.
Mm-hmm.
So you can share the data. So let's say you have a starting point here. You get an event, you get some data, and this data you can transfer along the steps. So you can easily, and this works with Lambda, and step functions is not just only with Lambda. Step functions can call the API of AWS service directly without using Lambda. Yeah.
That's really good. That's really powerful.
Yeah, that's pretty cool.
At the moment, no questions. No further questions.
Then I would say thank you so much. It was a pleasure. Thanks, Ali-chan, for your help. And take care.
Take care.